Novatra is a mold-making company specializing in multi-cavity molds for cosmetic, pharmaceutical, and medical plastic goods. They design, develop, and manufacture tools for injection machines. The design of a plastic injection mold requires collaboration between two processes, the mold making and the injection of the plastic. The shape and function of each mold can vary due to the typology, the type of plastic, and the number of cavities. The mold can be divided into two parts, the mechanical part, movement, guiding, centering, etc., and the molding part, cavities. Designs need to ensure that both functions are compatible. In the case of multi-cavities, the molded parts to be produced need to be strictly identical.
Les moules sont modélisés en 3D, puis un plan de chaque pièce est créé.
The molds are first designed in 3D, then a plan for each part is prepared for the manufacturing. The design needs to include the perfect kinematics to unmold the plastic part and the environment in which the mold will operate.
The design of a mold generally starts with an accurate analysis of the plastic part. The design process uses FEM software, which simulates the flow of plastic in the mold. This is important to check for any deformations, the pressure in the mold, and to anticipate any problems linked to the plastic injection under pressure. For the mold to work efficiently, it needs to have surfaces with very good roughness. The most important surfaces are the parting surfaces, where the core and the cavity join together when the mold closes, and the surfaces defining the part to produce. It is also important to have good surfaces for the ejection system.
Il est important de comprendre que la qualité des surfaces.
It is important to understand that the quality of the surfaces produced by printing is not perfect, and we must therefore do machining on the operational areas of the part. These areas will be determined beforehand in a virtual model by adding a volume of material. This virtual model, which is then printed, becomes the raw material of the workpiece to be machined.
The next phase is the part printing or additive manufacturing. This phase is done by Tronrud, a medium-sized engineering company based in Hønefoss, Norway. Tronrud have made metal AM parts since 2011 and have more than 20,000 machine hours on their EOS powerbed printers. In 3D printing, the metal powder is melted by the laser. In this case, a high-performance steel alloy is used. The powder that was not melted is then removed and the required part is obtained.
Når det så store og massive deler, blir det økonomiske konsekvenser.
When the parts are big and heavy, the economical consequences of errors in the printing process are severe, particularly if the faults occur late in the process. With CAxMan, we have the opportunity of simulating how the parts deform during printing, and we can adapt the design accordingly or optimize the orientation before we start. Another important function of CAxMan is in designing internal voids and cooling channels, as well as openings and channels to evacuate trapped powder.
The dimensional control step is done by Trimec, a leading company in the Spanish market in the field of coordinate measuring machines and measuring and digitalization software. After printing, the parts are 3D scanned to check that the additive manufacturing process has produced a compliant part. After the parts are milled to obtain the required smoothness and precision, they are scanned a second time to check that the geometrical and dimensional tolerances prescribed in the design phase are fulfilled.
Thanks to the
CAxMan project, we've been able to learn how to properly analyze complicated workpieces produced by additive manufacturing. Using a non-contact 3D scanner, the workpiece is scanned in order to check whether the established requirements are met through different graphical representations.
From the results of the dimensional control measurements of the block made with additive manufacturing, Novatra needs to put in position the final part in this block. To finish the process, the block is scanned a second time, and after that, the injection mold can be assembled. CAxMan offers a complete set of numerical calculation operations. The Competence Center will be at the disposal of other manufacturing companies that would otherwise not be able to generate it alone. The CAxMan solutions will allow Novatra to design more homogeneous cooling systems by creating 3D circuits. The use of numerical calculations will enable them to design lighter cavities that use less material and are cheaper to produce.